Hello students, in this video we'll discuss present value calculations for perpetuities immediate and perpetuities due. So we're going to discuss perpetuities. And these are of course infinite streams of payments. Payments that go on forever. Okay, and so here's the configuration that we're going to have. We're going to consider this situation where here we are at time 0. That's time 0, that's time 1, that's time 2, that's time 3, etc. That's time n, and then it just goes on forever. And what we're going to get for this perpetuity immediate, so this is the immediate situation, call these perpetuity immediates. You're going to get $1 at time 1, $1 at time 2, $1 at time 3, $1 at time n, $1 forever, right? So what you're going to have over here is, of course, the present value of this, the present value, in actuarial notation is denoted A infinity, I, is just going to be nu plus nu squared plus nu cubed forever. Goes on forever. And so we see this is exactly equal to, I'm going to plot 1 nu, and then I'm going to have a 1 plus nu squared, etc. forever. So these are equivalent to each other. Now we're going to use the geometric series formula. The geometric series formula is the following. Geometric series formula says that the sum n goes from 0 to infinity of x to the n is 1 over 1 minus x if the absolute value of x is less than 1. That's a geometric series formula. So I'm going to use that formula over here. And if we do that, we see that a bracket infinity, so a infinity I, is going to be nu, and then 1 minus nu. Now, nu, of course, is 1 over 1 plus I, so what I'm going to do is I'm going to multiply the top and bottom by 1 plus I. If I multiply nu by 1 plus I get 1. So I multiply the top and bottom by 1 plus I, 1 plus I. What I'm going to see over here is that's going to be a 1. I'm going to have a 1 plus I minus 1, so I just get a 1 over I. So a infinity bracket I is 1 over I. Now, if I do the annuity due, what will happen is this. The annuity due, perpetuity, it's the perpetuity, not annuity, sorry. Perpetuity. Due, the present value of this thing is going to be a double dot infinity I, and that is going to be start at 1 plus nu all the way up to infinity. And just by the ordinary geometric series formula, this is just 1 over 1 minus nu, right? And what I can do is I can recognize that the 1 minus nu is exactly equal to d, right? So because this would be 1 over I over 1 plus I, so this is going to be 1 over d. So 1 over d is the present value of a perpetuity due. Now let me do one final modification of this. There's a cool result we can do, and that is, what if I give you a stream of payments that starts to increase linearly as we go in time, right? So at time 0, you're going to get nothing. At time 1, you're going to have a $1. At time 2, you're going to have $2. At time 3, you're going to have $3, etc. At time n, you're going to get n dollars over here. And I'll have on the present value of this increasing annuity strain. So this going to be A, IA for increasing perpetuity, infinity I. And what's the present value of this thing? That's the present value of this stream is just going to be nu plus 2 nu squared plus 3 nu cubed, etc. forever. And so what this is this is equal to the sum, n goes from 1 to infinity, of n times nu to the power n. Now, I could also start this sum at 0 if I wanted to, and the cool thing about this is if I do the derivative of this formula, what will happen if I do the derivative of this formula? The derivative of this, so this of course is just 1 minus x to the negative 1, so if I did the derivative of this over here, I would just get 1 over 1 minus x squared. Excellent. So because I do the chain rule and I have the negative 1 on the power, so that's what I'll get when I do the derivative of this. So let's do the derivative of this series. So what will the derivative of the series be? That will be the sum. N goes from 0 to infinity of n x to the n minus 1. This will be equal to 1 over 1 minus x quantity squared. And of course, this sum is going to really start at, this sum starts at 1 because I can't have a negative 1 over here. So I'm going to start this sum over here at 1. And then what I'm going to do is I'm going to shift the index back down to 0. So what we have is we have almost something that we want over here. So what we have over here is we know that n times x to the n minus 1 gives me this thing over here. So if I multiply this series by x, that will correct that factor. So hence, x over 1 minus x squared is equal to the sum, n goes from 1 to infinity of n x to the power n. And now I can replace x with nu in this formula. So this increasing stream was going to have a present value of nu over 1 minus nu quantity squared. Now we know that 1 minus nu squared is equal to d, so this is going to be nu over d. And we can simplify that if we want to. We can use the various relationships between d and nu and I. To simplify this, we know that d is equal to I times v, right? And so we can use this, that's going to be d squared, of course, right? And we have the following formula. That's the formula for the present value of an increasing stream of annuity payments that linearly increment as you go further in time. Thank you very much.